Okay. In today's class, we are going to discuss about second chapter in fourth unit. In that, the first topic is what is an architecture? Why we are going for the architecture here? Okay. First of all, before going to know this architecture of a software, what is a architecture for building? What is an architecture for a building? We may say that a building architecture is the overall shape of a physical structure. If we take the example of a building architecture, so what it is? Building architecture in the sense it's a overall physical shape, overall physical shape or physical structure is called a building architecture, right? Or it is the degree to which buildings meet its stated purpose and specifies the needs of its owner. So whatever the owner is owner is wished to complete that building, which means how that building is look like. Okay, how many rooms he want in that particular building, and what is the size of that particular each and every room, and what is the color for that particular individual rooms or overall building. So everything related to a building construction is coming under a building architecture here. In a simple statement, we may say that it is an art. It is an art. If we'll take a what building, it's an art, complete picture, physical structure of a building. It may be rooms, it may be what areas, space. So everything. It may be a color. It may be related to a building. Everything related to building is called an architecture. Okay. So likewise, here, what is a software architecture here? What is a software architecture here? Right? So architecture of a system. Architecture of a system describes the components and how they fit together. Architecture of a system in the sense it's a what overall software system. It's a software system. Okay. So the architecture of a software system describes the components and how they fit together. How they fit together. And what is a component here? What is a software component here? Actually, it is a program module, or it is a object oriented class. We may call a software component of a architecture is something like it's an one program module is called a component, or or it may be an object oriented class, okay, which included some databases and some middleware technology, some network. So everything related to a complete project, everything related to a complete project is called a software architecture here, right? And this architecture is not the operational software. It's not the operational software. Okay, it representation that enables a software engineer to analyze the effectiveness of the design. So what it will give the instructions to a software engineer is, first of all, analyze the effectiveness of the design to meet the stated requirements. So whatever the structure we have designed for overall software, whichever we are going to construct, whichever we are going to construct, I mean get ready to use in such a state. Okay, first of all we would analyze the designing of a particular architecture. Okay, how it is work, if it will be implemented in real time. Okay, how it would be work, whether it is fulfilled all the requirements of a particular customer or not. Okay, we need to analyze how effectively that particular design is worked for a customer. Okay, we are designing one application, we are developing one application for the customer. So in designing state itself, if we analyze that particular, okay, overall structure of that project, then we may get some conclusion whether it is 100% suitable to the customer requirements or not. It will fulfill the requirements of a customer or not. How effectively it will reach the goals of a customer. We need to analyze that one. And coming to the second point, consider architectural alternatives. Okay, if that architecture maybe it's not like 100% fit into our 100%, it's not 100% fit into our particular what requirements of a customer, then you may select some other alternative architectures for that project, whichever suited, whichever best for the requirements of a customer, right? So it may be allow the programmers, okay, to add some changes after analysis. After analyzing the overall architecture, then in next stage, if it is something, okay, but a little bit not correct, which means it is deviated from the requirements of particular customer, then what we have to do, then at that place, at least at that place, we may modify that particular design. Okay, that architecture whatever we have designed, that would be allowed us to make some changes in designing phase itself. Now we are in architectural design also one of the designing element here. Okay, we are not moved to a construction phase, we are in still in designing phase. So if something, some what component or some coding is not suitable to that particular okay function, then what we have to do? Better to take another style, another pattern, isn't it? Okay, that is about second one. And third one, it reduces the risks associated with the construction of the software. Whenever we have some architecture, okay, architecture complete architecture, then by seeing that we may construct the code, isn't it? So if any kind of risks would occur, okay, that will be analyzed earlier itself. Okay, so the risks we may reduce in construction phase if you analyze that particular design in detailed manner at the design phase itself. So no need of worry while constructing that particular architecture, right? So these are the three important points of a architecture. And if we'll see the second side, why this architecture is important. What is the so why is architecture is important here? There are three key reasons are that architecture is important. Okay, because of these below three key reasons, okay, we may say that the software architecture is important. Okay, let us see one by one. What is the first key point? Representation of software architecture or an enabler. So, representation of software architecture are an enabler for communication between all parties. So, if we'll represent the overall architecture of a particular software project, then okay, it would be a okay, it would show important things related to a customer and developers. Okay, it establish some communication. It is like a communication between all the parties, which means all the parties in the sense it may be a stakeholder or developer. Okay, developers who are involved into that particular software project. Okay, so while seeing this particular architecture, they get some clear picture about that particular software project. Okay, in future, based on this particular architecture, we are going exactly we are going to construct the code related to that particular architecture. So this is the overview. Okay, I mean whatever the things we have added into this architecture. Okay, those are the components whichever we are going to use into our project. Like that, it's like a communication. Okay, thing. So same like a blueprint of a building construction. It is also but same thing. These are the one of the key point. It would show everything whatever the project includes and how the customer is going to okay interact with that particular project or use that particular project, how it would respond to that particular customer. So everything okay we should add it into that particular architecture. By showing that architecture to a customer, the customer may get some clarity about a software. I mean how they are going to what develop and how he is going to work with that, right? And coming to the second point of second point, the architecture highlights earlier design decisions. Okay, it will highlight the earlier design decisions. If anything is not what not interest not agreed by a customer, so he may ask for changes. Okay, something is not what flexible to use for a customer, then in such a cases also he may ask for changes. It is too difficult to use. Okay, to remember or otherwise or some any other extra activities he may request, right? So that's why some early design decisions. So if anything is added also, we may add it by getting some overall picture about that particular software system. Okay, so in previous in last last chapter also we have discussed that one. This is the phase for decision making. The design phase is a crucial phase. At this phase, okay, we make decisions, final decisions. After the designing phase, it's not possible to okay modify that much. Okay, so by understanding this architecture of a system, then any can some ask for us changes. That may be a developer, that may be a customer or anybody. So if it is finalized, then directly we may go for a construction phase. Right. The third key point is architecture constitutes a relatively small, okay, in, intellectually graspable mode, and which means how the system is structured and how the components work together. Okay, it will give a an information about how the components are, okay, involved into that particular software system, and how they will be worked together, how that is structure, what is the overall view of that particular system. Okay, it will show to the customer or for anybody whoever involved into that particular software system, isn't it? So how the system is structured and how the components work together. So these are the three important key points about importance of an architecture, right? Next, the next topic is architectural genres. What is genre here? It is a one kind of style. It's a style, okay, or it's an art related to a architecture, related to a architecture. Now we are going to talk about some system architecture, okay, how the systems would build and which kind of things it may be considered, how many kinds of styles are there for a particular system, okay, to develop a particular system. So which kind of styles we may take. So that is the thing here we are going to learn about architectural journey genres. So coming to the first one, see the first point. Genre implies a specific category. It implies what it implies. It's a specific category within the overall software domain. Within the overall software domain. So the software domain may have okay different categories, different things. Okay, so many domains are there, software domains. I mean, where we are using this software, all are the fields which it may be. I mean, in next slide we are going to discuss about that many domains of your software, right? Now just we'll discuss about a genre. Genre in the sense it's one kind of a specific category or specific style related to a architecture here, right? So within each category, you encounter a number of subcategories. If you take a single category, okay, you may have multiple number of subcategories. Okay, for example, within a suppose the genre related to a building, the genre related to a building, how would encounter the general styles related to a building. So the building may be a house, it may be condos or apartment buildings or office buildings or industrial buildings, warehouse, etc. If you will talk about one building, how many categories the building has? Normal houses, apartments, it may be some what office buildings or industrial buildings or warehouses. Okay, these are the different kinds of okay, here the different kinds of styles are there for a building, isn't it? So like in same, and within each general style more specific styles might apply. Each style would have structure that can be described using a set of predictable patterns, set of predictable patterns. If it is a house, it has some patterns. If it may be apartment, okay, it has some styles. And it may be a office building, okay, it is some little I mean room sizes and some thing, I mean the things whichever used in office buildings are little different. and it is an industry building. Industry building in the sense, okay, there are more things we have added into that buildings. So these are the different styles related to a building like that here. Okay, we are going to discuss about the different styles whichever we are included into a each and every domain of a, okay, software. We are going to add some styles, some symbols, some colors, okay, the specific things related to a styles of software architecture, right? We'll see the next slide. These are the some, okay, generic examples for software systems. Okay, so what are the styles we are applying the architecture? So where we are applying some styles to that software architecture, okay, in different domains of software. What are those domains? Okay, it may be artificial intelligence, it may be devices, sports domain, financial, games, medical, scientific, okay, transportation, government, etc. Here the software is built for these many purposes. And even also education, okay, I think it's not there here. Okay, sports purpose, financial status purpose, games purpose, medical purpose, and scientific, transportation, government, and these are the different areas. Even though educational institutions, okay, these are all the different areas which are frequently used by these applications, software applications. Based on the based on this what domain, we may have different styles, we may have different architectural styles and different patterns here, right? Suppose if it is a if it is a medical if it, for example, if we take a small medical example here, we are developing an example related to a some medical, okay. So how we are going to use some colors, some designs, for particular of application colors and designs, okay, it's almost suitable, okay, to that medical, I mean, how the medicos are interested, and how, I mean, hospital, which means how the clients are showing the interest on that particular what things, and what suppose doctors or different people, whoever the, okay, customers of that particular app, and based on their, I mean, based on in their view, we are going to develop that particular app here. If it is educational society means, okay, students are the, okay, users of that particular apps. So how the students are showing interest on that particular apps, like that we are going to design. If it is a game, if it is a game, so that game is what which kind of game we are going to develop, okay, who are the users for that particular game? The users are, okay, middle aged people or old age people or the children's or the or the what, youngers. So based on their interest, we are going to develop, I mean, that particular game. We are going to add some what colors or designs or styles to that particular app here, right? This is the example for software system, generic examples for the software system here, right? Right. Next here, the same, the genre in the sense it's a style now. So now we are going to discuss about the architectural styles. This is the next concept. What it is? It is a architectural style here, right? Our okay, what is software architectural style here? In as well as like building styles, our architecture is also having some styles. Some of softwares also exhibit some styles here, like however that what a house maybe, I mean, house construction, house design is we have many different what models or styles are available now. So like that, the software is also having different style. Okay, each style describes a system category. Each style describes a system category that encompasses. First one is a set of components here. A set of components that may be a database computational modules that perform a function required by a system. Okay, so our software, computer based software is also having many architectural styles. Each style describe a system category, and first one is a set of required set of set of required components here, set of components here, okay, that perform a function required by a system. So whatever the component, the individual components are used to perform a individual function which support a system. And next one, set of connectors. So connectors are used to, okay, establish, I mean, connection between the different number of components for communication and coordinate the things whichever we are working with, which may for example, here we have number of functions. So like for example, uh, our regular example is ATM. That ATM module has a number of functions here. So sometimes there is a chain link between one function to another function. Okay, what is the first function? If suppose if you want to change the or inquire the, if you want to go for a inquiring a balance, inquiry of our account balance, then how that particular thing would be executed, that function would be executed after completion of that function. Okay, whether we will come out from the overall system or we want to proceed to a continuation of a transaction for any other transaction, like that we may link up that particular function to another functions. Okay, instead of coming completely out of from that is ATM mission, right? So that kind of things would occur, I mean, would come under the connectors, right? And also some constraints. What are the constraints are there while defining this particular components and integrated with each one, which means what are the conditions, what are the problems we may face while designing these components, uh, or while communicating with these components, right? How those would be, but I mean, overcome, right? And next, semantic. The fourth one is semantic modules that enables a designer to understand the overall properties of the system. Okay, so what are the overall properties of this particular system would coming under a semantic models. So by developing these, okay, with little bit by adding some styles to develop these components and connections, and if there any what rules and regulations to made up these what components with connections, and also so overall the properties of the system, These can be built by using some little, okay, by exhibit some little styles into this. Okay, so if you will observe this what panel, I mean which ATM panel means it is designed with some other options. Okay, the designs we may change a little bit means, okay, it would be very aesthetic, like aesthetic nature, which means it's very interested to use not only one time, many times. If something is attracted us, then we may interested to use multiple times, isn't it? If one design, one style, or one application, okay, would attract the customer's view, then that people are interested to use that particular thing multiple times, isn't it? So that is purely based on a, okay, designs and also designing styles, okay, or colors or combinations, whatever we are using on that particular thing. If you will observe that Google Google page, a search engine page, always he has changed that Google word is there na, Google, that every day he may give some new design to that particular Google word. Why? Because this is one kind of okay, attraction. Okay, or if you'll observe that Google word, every day one design would come along with. This is one kind of styles to that particular Google. For which purpose? It is for grabbing the concentration of a user or customer. It grabs the view or something. Okay, customer view. For such a for that, okay, they change the styles every time. Not only that, if you'll observe nowadays, the Gmail symbol is also changed. Yeah, I mean, what some mail symbol M is what designed with multiple colors. Previously, it is the only single color. It's a red color symbol. If you'll observe that, in olden days, a mail Gmail, if you'll open your Gmail account, some M symbol will come. Okay, that M symbol in olden days it's just red color, but nowadays it's a multiple number of colors. It is a little bit adding the colors or styles to that particular M word. Okay, grabbing the customer's view. That is only for. So like that, our software architectures also need different styles here. Okay, then only the people are interested to, okay, use our particular application. So the designs the designs and styles also play important role in every software project, isn't it? Okay, next we have the taxonomy of styles in software. Okay, there are six styles are there. We will discuss in tomorrow's class. Okay, for today I'm going to stop the class.